Hi guys, it's Miss Lee, and this is our last video lesson on solving one-step inequalities. This particular lesson is solving one-step multiplication and division inequalities, but with negative rational numbers. Okay, in our last video, we learned how to solve multiplication and division inequalities, but the numbers were positive. The numbers that we multiplied and divided both sides by were positive rational numbers. Now we're going to talk about negatives because it's a little bit different. So make sure that you have your notes out and that you're filling them out as we go along. Pause the video if necessary so that you can stay caught up. Okay, we have one more multiplication and division property of inequality. And it says that if you multiply or divide both sides of an inequality by the same negative number, you must reverse the inequality symbol for the statement to still be true. Okay, what do they mean? Well, I'm going to take this example here. Negative 2x is less than 6. Okay, we know to isolate our variable x, we're going to have to undo this multiplication. And the operation that undoes multiplication is division. So instead of multiplying by negative 2, we're going to divide by negative 2. And what we do to one side, we have to do to the other. So here we're dividing both sides of our inequality by a negative. This is when you have to flip the inequality symbol. You reverse it. Instead of being less than, it's going to be greater than. The same thing if this was your problem. Here, this is division. We're dividing the variable by a negative. So to undo, we have to do the inverse operation, which is to multiply by negative 2. Which means if we're going to multiply the left side by negative 2, we have to multiply the right side by negative 2. So here we're multiplying both sides by a negative number. You have to flip the inequality. If it was a positive number, then you would be fine. You would not have to flip it. It's only if you're multiplying or dividing both sides by negative. Not addition and subtraction, guys. Just multiplication or division by negatives. Okay, why do we do that? I can tell you, yes, you have to do that, but I want to show you why that happens. So I'm going to show you, the best way to show you is through the models. So here, the inequality has been modeled with our algebra tiles. We have 2 negative x tiles on the left side, 6 positive unit tiles on the right side. Now, never, ever, ever, ever should you hear or have you heard your teacher ask you to solve for negative x. Yes, go solve that equation for negative x. Yes, go solve this inequality for negative x. We don't want to find the value for a negative x or a negative variable. We want to know the positive. It's always, what is x? Solve for x. It's never solve for negative x. So we need to turn, step 1 is to turn these negative x tiles into positives. And no, you cannot go just draw a line, a vertical line, to make them positive symbols. We need to somehow remove these negatives. And the way that we know how to remove negatives are to zero them out. And to zero them out, we need to put 2 positives. Because a negative with a positive will zero out. So we're adding 2 positive x tiles to the left side. We have to do the same thing over here to the right side. And now we can pull out our 0 pairs. I'm going to loop it and I'm going to pull it out. And I have no 0 pairs over here on the right side. So what I'm left with is nothing on the left side, 6 positive units and 2 positive x tiles on the right side. And it's okay because we're not done yet. We're going to keep going. And now we get to where we do what we need to do. We need to isolate the variables, isolate the x tiles. So we're going to have to do something with these 6 positives. And again, we don't just erase them, but we know we can make 0 pairs. 0 pairs will cancel out these 6 positives. And if we're going to add 6 negatives over here on the right side, then what do we need to do to the left side? Add 6 negatives. There we go. Then I can go ahead and pull out my 0 pairs. And I'm left with 6 negatives on the left side two positive x tiles on the right side, just like this. See? And our x tiles are now positive, which is what we want. But we don't want to know the value of two x tiles. We're not solving for 2x. We want to know the value for one x tile. And this is where you're going to take these 6 negatives and you're going to split them into 2 equal groups. And each x tile will get 3 negative units. So it's going to be -3. Bring down your inequality symbol is less than x. This is going to be your solution. Now some of you may say, but wait a minute, I thought the inequality symbol was supposed to switch. What really switched was the x. In our original inequality, the x is over here on the left side, but in our answer, the x is on the right side. So I can go and I can rewrite this with the x on the left side. X is greater than -3. Now compare. Here, our inequality is greater than, but originally, when x was on the left side, it was less than. So our inequality symbol has switched. It has flipped. And that's what you're going to do to solve. So when multiplying or dividing by a negative number, we're going to go ahead and switch the inequality sign. So let's do this example. I still want to see the left and the right side clearly, so I draw my line. X is being multiplied by a negative. The inverse operation to multiplication is division. So we're going to divide by a negative. We're going to divide by -3 on both sides. This is where I stop and I say, oh, I'm dividing by a negative on both sides. Let me switch my inequality. Instead of greater than, it's going to become less than. Now I can go ahead and simplify. -3 divided by -3 is a positive 1x, or just x. And 15 divided by -3 is a -5. So x is less than -5. And you see how I switched the inequality. Now what would have happened if I did not switch it? If I had gotten x is greater than -5. Well, if you're checking, which I know a lot of you are not checking because you want to hurry up and speed through your work, but if you're checking your answers, then you would find out that it's wrong. Let's replace x in our original inequality with a number greater than -5. A number greater than -5 is 1. So I'm going to put -3 times 1 should be greater than 15. Well, what is -3 times 1? It's -3. Is -3 greater than 15? No, it is not. No, it is not. So we did something wrong here. This should be a clue to you to go back and look at your work and realize, oh, I'm dividing both sides by negative. I have to flip the inequality. So now let's check what we really got. X is less than -5. A number that's less than -5 is -6. So go back to our original inequality. -3 times a -6 should be greater than 15. Well, a negative times a negative is a positive 18. Is that greater than 15? Yes, it is. Okay, I'd like for you to go ahead and complete problem A on your own. Pause the video. I want you to solve it, check your answer, and graph your solution. Once you're done, come back and check your work. Okay, let's see how you did. Did you get that y is greater than -6? If you did, great job. If you didn't, quickly take a look. We want to do the inverse operation of multiplication, which is division. We're dividing both sides by a negative. Did you flip or switch that inequality symbol? When I checked it, I substituted a value for y that was greater than -6, so I chose -5. And I got 50 is less than 60, which is true. And then this is what your solution graph should look like. If you did not flip your inequality symbol, then if you checked it, you should not have gotten a true statement. Your statement should have been false. Okay, one more example. 7 is greater than or equal to -t divided by 6. Okay, a lot of times you're going to see the negative sign in front of this, what looks like a fraction here, t divided by 6. We don't want to solve for a negative variable, do we? So we're going to put this negative sign with the constant, with the 6. So I'm going to write it here so I don't forget that and kind of cross it off here. And now I'm ready to do the math. I need to do the inverse operation of division, which is multiplication. So I'm going to multiply by -6. Do the same thing over here on the left side. Ooh, look, I'm multiplying both sides by a negative. So let me switch my inequality. Instead of greater than, it becomes less than. Now, it also has this equals bar. That doesn't change. That will stay the same. So instead of greater than or equal to, it becomes less than or equal to. And we can simplify here. Multiply -6 times 7 is -42. And the sixes, the -6s, they simplify to 1, t over 1, which is just t. So our solution is -42 is less than or equal to t. So let's check it. Come back to our original. 7 is greater than or equal to. We want to replace t with some value that is greater than -42. Now if you look, we're actually dividing by -6. So I'm going to be smart about this, and I'm going to choose a value that is a multiple of 6. Okay, but it has to be greater than -42. So I'm going to choose -36. I'm sorry, I'm going to choose 36. Not negative, but just 36. All right, so let's do the math here. 7 is greater than or equal to 36 divided by 6 is 6, and it's a -6 because we're divided by a negative, a positive divided by a negative. Is 7 greater than or equal to -6? Yes, it is. And then you just graph your solution on the number line. Here's the -42. T is greater than, so our T line is going to go to the right. Our circle is going to be filled in because it's equal to. Okay guys, great job. You're now ready for your independent practice.